Picture this. It's the middle of a sweltering July afternoon in Phoenix, 1976. The asphalt is soft enough to leave footprints, and inside the service bay of Chapman Chrysler Plymouth, the air is thick with the smell of unburnt hydrocarbons and frustration. A mechanic is bent over the fender of a '75 Chrysler Cordoba. It's a beautiful car, really. Rich Corinthian leather, sweeping lines. But under the hood, it's a disaster. The owner has brought it in 3 times this month. It stalls at lights, it surges on the highway, it gets fuel economy that would make a tank commander blush. The factory service manual says to check the sensors. Again. It says to recalibrate the computer. Again. But this mechanic, a guy named Eddie, does something else. He ignores the manual. He picks up a 9/16 wrench, loosens the distributor hold-down bolt, and rotates the entire unit clockwise. Not a little bit. He turns it a massive 17 degrees past the factory limit. He locks it down, he wipes his hands, he sends the car out, and like magic, the stalling stops. The hesitation vanishes. The fuel economy jumps by nearly 30%. He just fixed what millions of dollars of corporate engineering couldn't. And in doing so, he just painted a target on his back. This is legacy motoring, and I spend way too much time thinking about the forgotten engineering battles of the 20th century. If you're someone who loves mechanical justice and hearing about the little guy outsmarting the corporate machine, make sure to hit the subscribe button and give this video a thumbs up if this helps you out. Here's the thing. To understand why a simple twist of a wrench became the most controversial modification of the 1970s, you have to understand the sheer panic that was gripping Detroit at the time. We look back at the 70s now and we laugh about the polyester and the disco, but for the automotive industry, it was practically the apocalypse. You had the Arab oil embargo in '73 that quadrupled gas prices overnight. Suddenly, nobody wanted big V8s. Then you had the government stepping in with the Clean Air Act, mandating catalytic converters and unleaded fuel for 1975. This was a 1-2 punch that knocked the wind out of the big three. General Motors and Ford, they had the cash reserves to weather the storm. They just bolted catalytic converters onto everything, detuned their engines until they made less horsepower than a lawnmower, and called it a day. But Chrysler was in trouble. They were the smallest of the big three. Their cash flow was tight, and they were desperate for a Hail Mary. They couldn't afford to just make their cars worse and hope people bought them anyway. They needed a miracle. So their engineers came up with something that sounded brilliant on paper. It was called the electronic lean burn system, and honestly, the theory was sound. See, a standard car engine burns fuel at a ratio of about 14.7 parts air to 1 part fuel. That's the stoichiometric ideal. It's safe, it's chemically balanced, but Chrysler's engineers thought, what if we starve the engine of fuel? What if we run it at 18-to-1 or even 20-to-1? If you can pull that off, you get 2 huge benefits. 1, you use less gas, obviously. 2, and this is the kicker, if you burn the fuel with enough excess air, the combustion is cooler and you produce fewer oxides of nitrogen, or NOx. That meant, and this was the holy grail, Chrysler could meet the 1975 emission standards without using a catalytic converter on some engines, or at least without choking the engine to death. They could advertise power and economy while Ford and GM were selling wheezing barges. It was a billion-dollar idea. There was just one tiny problem. It didn't work. Well, let me rephrase that. It worked in the lab. In a perfectly controlled environment with steady temperatures and high-quality fuel, the lean burn system was a marvel. But out in the real world, it was a nightmare. And here's what most people don't realize about the lean burn system. It was the world's first attempt at mass-market computer-controlled ignition. Today, your car has a computer that can process millions of instructions per second. It's got NOx sensors, O2 sensors, mass airflow sensors. It knows what the weather's like in the next county. The 1976 lean burn computer? It was basically a glorified toaster oven with a few transistors glued to it. It was an analog computer, not a digital one. It tried to read engine vacuum, throttle position, and coolant temperature, and then decide when to fire the spark plug. But it was slow. It was physically mounted on the air cleaner, right on top of a vibrating hot V8 engine. I mean, think about that. You're taking sensitive 1970s electronics and shaking them to death while baking them at 200 degrees. What could possibly go wrong? The result was a system that was terrified of itself. See, running an engine lean is dangerous. If you get it wrong, the engine gets too hot. It starts to detonate. That's when the fuel explodes instead of burning smoothly. Detonation is like hitting your piston with a sledgehammer. It breaks things. So Chrysler's engineers, terrified of blowing up engines under warranty, programmed the computer to be incredibly conservative. They pulled the ignition timing way, way back. Now, you might be thinking, okay, so the timing is a little retarded, who cares? But ignition timing is everything. It's the heartbeat of the engine. You have to fire the spark plug before the piston reaches the top of its stroke, so the explosion has time to build pressure. If you fire it too late, the piston's already moving down by the time the fuel burns. You lose power. You waste heat. The engine feels lazy, like it's waking up from a nap. Chrysler's computer was firing the spark so late that the engines were basically dead on arrival. We're talking about massive 400 cubic inch V8s that struggled to merge onto a freeway. And because the spark was so late, the fuel wasn't even finishing burning inside the cylinder. It was still burning when the exhaust valve opened. So you're dumping raw burning fuel into the exhaust manifold. This made the engines run incredibly hot, which ironically made the cooling system work harder, which made the underhood temps higher, which cooked the computer even faster. It was a death spiral of engineering failure. But Chrysler had committed. They had marketed lean burn as the future. They couldn't admit it was a dud. So when customers came in complaining, and they came in droves, dealerships were told to just swap out the computer or check the sensors. Mechanics were replacing parts blindly. They'd put in a new spark control computer, the customer would drive away happy, and 3 weeks later, the vibration would kill the new unit and they'd be back. It was a mess. Dealerships were losing money on warranty claims, customers were defecting to Honda and Toyota, and in the middle of this chaos, in that sweltering shop in Phoenix, Eddie Martinez was watching. Eddie wasn't an engineer. He didn't have a degree from MIT. He grew up fixing cars in East LA before he was old enough to have a license. He understood engines not as mathematical equations, but as living things. He listened to them. And what he heard when a lean burn Chrysler pulled into the bay wasn't a broken computer. He heard an engine that was gasping for air and begging for a spark. While other mechanics were following the corporate flowcharts, Eddie started experimenting. He realized that the lean burn distributor, the mechanical part that spins around to distribute the spark, was physically identical to the old distributors from the early 70s. But inside, it was gutted. The mechanical advance weights, which are supposed to advance timing as the engine speeds up, were locked down. Chrysler had neutered the mechanical system to let the computer do the work. But the computer wasn't doing the work. That was the epiphany. The computer was programmed to add timing on top of a baseline, and that baseline was set at the factory to be effectively 0. Eddie had a thought that was so simple it was almost dangerous. What if I just lie to the computer? Look, if the computer assumes the timing is at 0 and adds 10 degrees, you get 10 degrees total. Pathetic. But if you mechanically rotate the distributor so the baseline is already 15 degrees, and then the computer adds its 10 degrees, now you're at 25. Now you're in the power band. Now you're actually burning the fuel. So one quiet Saturday, he tried it on a customer's car. He didn't ask for permission from Detroit. He just loosened that bolt. He turned the distributor until the engine idle smoothed out. He listened. He revved it. He turned it a bit more until he heard a tiny ping of detonation, and then he backed it off just a hair. When he put a timing light on it, he realized he had advanced the timing a staggering 17 degrees beyond what the sticker on the hood said. In the world of mechanics, that's an eternity. That's like setting your oven to 600 degrees to bake cookies. It shouldn't work. It should melt the pistons. But he took it for a test drive. And this is where it gets really interesting. The car didn't blow up. It woke up. The car didn't just accelerate. For the first time in its life, it actually drove. The hesitation off the line was gone. That dangerous stumble when you tried to merge onto the three-way, replaced by a smooth, linear pull. Eddie brought the car back to the shop and the customer took it for a spin. They came back 20 minutes later with the look on their face that every mechanic lives for. Pure, bewildered relief. They asked, "What did you do? Did you replace the engine?" Eddie just smiled and said, "I just set it up the way it wanted to be." Now, you might be thinking, okay, cool story, but surely this was a fluke. Maybe that one specific Cordoba had a weird sensor or a loose vacuum line. But Eddie was a scientist in grease-stained coveralls. He knew that in the automotive world, one data point is an anecdote, but three is a pattern. So he started doing it to every lean burn car that came through the bay complaining of poor performance. And in 1976, that was basically every lean burn car. He kept the logbook, a simple spiral-bound notebook tucked in his toolbox, and the numbers he started recording were absolutely damning for Chrysler. A 1975 Dodge Coronet with a 318 V8 came in getting 11.3 miles per gallon. After the Martinez 17-degree twist, it was getting 14.5. That is a 28% improvement in fuel efficiency, just from turning a distributor. Think about that for a second. Today, manufacturers spend hundreds of millions of dollars to squeeze a 3% efficiency gain out of an engine. They redesign transmissions, they use exotic lightweight materials, they put shutters on the grille to improve aerodynamics. Eddie got 28% with a wrench in 5 minutes of his time. Another customer with a Plymouth Fury and the bigger 360 engine complained the car was gutless. Eddie worked his magic. The customer swore it felt like he'd bolted on a supercharger. Later dyno testing, yes, people actually put these cars on dynamiters to verify this, showed that while it gained about 12 to 15 horsepower at the peak, the low-end torque and throttle response were transformed. It wasn't just making more power, it was making power sooner. Here's the thing. To understand why this worked so well, you have to visualize what's happening inside the engine. Picture a child on a swing set. You want to push them to keep them going high. If you push them when they are already moving away from you, you add energy. But if you try to push them when they are still coming toward you or right at the very bottom of the arc, you kill their momentum. Ignition timing is exactly the same. The piston is a child on the swing. The explosion of fuel is your push. You have to light that fire before the piston reaches the top so that by the time the explosion fully expands, the piston is just starting to go down. That is the sweet spot. Chrysler, in their fear of detonation, was waiting until the child was already halfway down the slide to push. They were wasting all that energy. By advancing the timing 17 degrees, Eddie was simply timing the push correctly. Word started to spread, and this is where the story shifts from a mechanical curiosity to a corporate thriller. We didn't have the internet in 1975. There were no forums, no subreddits, no YouTube comments, but mechanics have their own telegraph system. It happens in the break rooms of parts stores, in the waiting areas of machine shops. One mechanic tells another, "Hey, you got a stumbling Cordoba? Crank that distributor until it pings, then back it off 2 degrees." Within 6 months, Eddie had personally modified over 200 cars, and not a single one came back with engine damage, not one burned piston, not one blown head gasket. In fact, the cars were actually running cleaner. Because the fuel was burning completely inside the cylinder, the catalytic converters didn't have to work as hard. They were passing emissions tests easier than the stock cars. But you can't hide 200 happy customers forever. Eventually, the suits in Detroit started hearing rumors. Dealerships in the Southwest were reporting a sudden drop in warranty claims for drivability issues. Customers were canceling orders for replacement computers. Chrysler's regional representatives started asking questions. In December of 1975, the hammer dropped. Chrysler issued Service Bulletin number 75-43-04. It had a boring title, Lean Burn Ignition Timing Specifications, but the text was a declaration of war. It explicitly stated that unauthorized timing modifications were being reported in the field, and that this practice must cease immediately. It warned that any deviation from factory specs would void the warranty. It threatened that dealers could lose their franchise licenses. But here's the part that really tells you everything you need to know about corporate culture. The bulletin didn't say why it was bad. It didn't cite a single case of engine failure. It didn't provide a chart showing increased emissions. It just said, don't do it. It was the engineering equivalent of a parent saying, because I said so. Eddie's service manager called him into the office. Now, this manager liked Eddie. He liked that Eddie fixed cars that nobody else could fix. But he had a regional rep breathing down his neck. He showed Eddie the bulletin. He said, "Eddie, this is great work you're doing. The customers love it, and that is exactly why you have to stop." He explained that by fixing the cars, Eddie was embarrassing the engineering department. He was proving that the factory setup was flawed. And in the corporate world, being right is often more dangerous than being incompetent. If Eddie was right, it meant Chrysler was selling defective cars. It meant they might be liable for recalls. It meant lawsuits. Eddie, being the stubborn genius he was, didn't back down. He asked the rep, "Show me the data. Show me one engine I've broken." The rep couldn't, so Eddie made a choice. He wrote a letter, not to his boss, but to the president of Chrysler. He laid it all out. The MPG gains, the happy customers, the lack of damage. He offered to fly to Detroit and demonstrate the fix to the head engineers. He thought, genuinely, that they would want to know. He thought they would say, "Oh wow, we missed this. Thanks for saving us." 3 weeks later, he got a response. It wasn't a thank you note. It was a letter from Chrysler's legal department threatening to sue him for unauthorized modification of emissions equipment and endangering public safety. They gave the dealership an ultimatum: fire the mechanic or lose your franchise. In January 1976, Eddie Martinez packed his toolbox. He was fired for the crime of making cars work better than the factory intended. But Chrysler made a fatal miscalculation. They thought that by cutting off the head of the snake, the idea would die. They thought they could bully the truth into submission. Instead, they turned Eddie into a martyr. And they turned a simple mechanical adjustment into a nationwide underground revolution. Here's what most people don't realize about secrets. Trying to suppress them is the fastest way to ensure everybody hears them. In the internet age, we call it the Streisand effect. In 1976, they just called it good copy. Chrysler thought firing Eddie would bury the story. Instead, it was like tossing a lit match into a warehouse full of gasoline. The automotive press got wind of the scandal. Popular Mechanics ran a piece with a headline that would make a modern clickbait writer jealous: "The timing trick Chrysler doesn't want you to know." Hot Rod magazine published the exact specifications. Car and Driver did an investigative deep dive into the failures of the lean burn system and framed Eddie not as a rogue mechanic, but as a folk hero. Suddenly, mechanics across the country weren't just whispering about the modification, they were advertising it. Independent shops started putting up signs: "We fix lean burn problems." It became a badge of honor. You weren't just getting your car tuned, you were joining the resistance. You were opting out of the Malaise Era and reclaiming the performance that the government and the corporations had stolen from you. By the spring of 1976, the Eddie Martinez timing trick had gone viral, and the only way things could go viral back then, through human networks. Car clubs organized tuning days in shopping mall parking lots. Imagine a sea of polyester-clad guys leaning over the fenders of Cordobas and Monacos, passing around timing lights and 9/16 wrenches like they were contraband. Knowledgeable members would walk down the line, listening to engines, nodding, and giving the thumbs up when the timing was set just right. It was mechanical democracy in action. Chrysler's response was to double down. If they couldn't stop the information, they would stop the hardware. For the 1977 model year, they introduced a redesign that was purely spiteful. They rolled out a new distributor with a tamper-resistant hold-down mechanism. The bullhead was designed so that a standard wrench would just slip off. You needed a special tool to loosen it, a tool that Chrysler only sold to authorized dealerships. They also updated the computer programming. The new Spark control computer was designed to detect the specific vacuum signature of an engine running with advanced base timing. If it sensed you had messed with the distributor, it would throw a check engine light. Now, you might be thinking, game over, you can't fight the factory. But this was the 1970s. A check engine light back then was basically a suggestion. Most people just put a piece of black electrical tape over it and kept driving. And as for the tamper-proof bolt, mechanics had that figured out in about 48 hours. Someone realized that if you took a standard socket and ground down the sidewalls or just used a pair of vice grips and some patience, you could defeat Chrysler's security in minutes. Aftermarket companies even started selling lean burn adjustment kits that included the special wrench and a set of instructions on how to bypass the computer's crude tamper detection. The cat and mouse game just made the modification more sophisticated. Eddie's original trick was a blunt instrument, rotate the whole distributor. But as thousands of mechanics started experimenting, they refined the science. They discovered that different engines wanted different flavors of the trick. The 318 cubic inch V8, the workhorse of the fleet, loved big advance. It was happy at 16 to 18 degrees. But the larger 360 cubic inch engine, it was a bit more sensitive. It preferred 14 to 16 degrees. The massive 400 cubic inch big block, you could crank that thing to 20 degrees in some cases, and it would just pull like a freight train. Mechanics also realized that you could combine the timing trick with other adjustments for a multiplier effect. They started recurving the distributors. This involved opening up the distributor and changing the little springs and weights inside that controlled the mechanical advance. By putting in lighter springs, they allowed the timing to advance faster as the engine revved up. This gave the car a snappy, responsive feel off the line that the stock lean burn system had completely strangled. Chrysler dealerships were caught in an impossible position. Corporate was sending them memos threatening their franchises if they performed unauthorized modifications. But customers were coming in and saying, "Look, my neighbor's Cordoba runs great because he went to Eddie's shop. Fix mine or I'm taking my business there." Some dealers played it by the book and watched their customers walk away. But the smart ones, they learned to operate in the gray area. They would perform the modification but leave it off the official paperwork. The repair order would say tune-up and sensor adjustment, but the mechanic in the back was twisting that distributor 17 degrees. It became an open secret. The service managers knew, the mechanics knew, the customers knew. The only people pretending it wasn't happening were the executives in Highland Park. And this is where geography played a huge role. The Southwest Tuning School became legendary. In states like Arizona, New Mexico, and Nevada, you have two things: high heat and high altitude. At higher elevations, the air is thinner. Less air density means less cylinder pressure, which means the engine is naturally less prone to detonation. You can get away with way more timing advance in Albuquerque than you can in sea-level Boston. Mechanics in the desert were running aggressive timing curves, 20, 22 degrees of base advance with zero issues. The hot, dry air just ate it up. In California, however, things were trickier. The Golden State had the strictest emissions testing in the country. If you advanced the timing too much, you might inadvertently raise your NOx levels just enough to fail a smog check. So California mechanics developed the Goldilocks tune. They would advance it just enough to fix the drivability problems, maybe 10 or 12 degrees, but not enough to trigger the smog sniffers. They were threading the needle between performance and compliance, and they were doing it better than the factory engineers. By 1977, Chrysler was facing a rebellion from within. Their own service network had effectively unionized against the engineering department. Internal memos that were later uncovered during lawsuits, because of course there were lawsuits, revealed that Chrysler's engineers knew exactly what was happening. They had field reports showing the MPG gains. They had dyno charts confirming the horsepower numbers. In one particularly damning memo, a junior engineer suggested that maybe, just maybe, they should adopt the field modification as the new factory standard. He argued that it would solve the warranty complaints and improve customer satisfaction. His proposal was shot down immediately. The response from the legal department was chilling. To adopt the unauthorized procedure would be an admission that the original design was defective, exposing the corporation to retroactive liability. Read that again. They didn't reject it because it was wrong. They rejected it because admitting they were wrong was too expensive. They chose to keep building cars they knew were inefficient rather than risk a lawsuit. So they buried the evidence. They transferred the engineers who asked too many questions to different departments, usually somewhere unglamorous like seatbelt tensioner testing. They threatened anyone who spoke up. They hoped that if they just ignored it long enough, the problem would go away. But the timing trick had become more than just a way to save gas. It had become a test of whether truth could survive corporate denial. Eddie Martinez had started a fire that Chrysler couldn't put out, no matter how many memos they wrote. And as the 1970s dragged on, the engineering truth began to expose the corporate lie in ways that nobody, not even Eddie, could have predicted. Here's the thing. We've talked about the politics, the rebellion, and the corporate intrigue, but at Legacy Motoring, we don't just care about the drama, we care about the machinery. We need to understand why Eddie's modification worked so well from a pure physics standpoint, and why Chrysler's engineers, who, let's be fair, were smart people, got it so wrong. To get it, you have to stop thinking about an engine as a machine and start thinking about it as a chemistry experiment happening 40 times a second. Ignition timing is all about pressure management. When the spark plug fires, the air-fuel mixture doesn't explode instantly like a stick of dynamite. It burns. It's a flame front that starts at the plug and propagates outward across a combustion chamber. This takes time. It's measured in milliseconds, but at 3,000 RPM, a millisecond is a lifetime. Your goal as an engine tuner is to time that spark so that the maximum pressure inside the cylinder occurs just after the piston has passed top dead center and is starting its way down. This gives you the best mechanical leverage to push the crankshaft. If you light the fire too late, which is what the stock lean burn system was doing, the piston is already racing away from the explosion by the time the pressure builds. You're chasing the piston down the hole. It's inefficient, it's weak, but more importantly, it creates massive amounts of waste heat because the energy isn't being turned into motion. It's being absorbed by the cylinder walls and the exhaust valves. So why did Chrysler do it? Why run the timing so retarded that it crippled the engine? It all comes down to one word: fear. Specifically, fear of the unknown qualities of unleaded fuel. You have to remember, 1975 was a transition year. For decades, American engines ran on leaded gas. Lead is a fantastic octane booster. It suppresses detonation and lubricates valves. When the government mandated unleaded fuel, Detroit panicked. They were convinced that this new clean gas was unstable garbage that would cause engines to knock themselves to death if you looked at them wrong. Chrysler's engineers assumed the octane rating of unleaded fuel was going to be inconsistent and low, so they built a safety margin into the timing, a massive, comical safety margin. They tuned the engines for the worst-case scenario, a tank of bad gas on a hot day, towing a trailer uphill. But Eddie Martinez proved them wrong. His modification demonstrated that modern unleaded fuel was actually much more robust than the engineers gave it credit for. It could handle significant advance. Engines running 18 degrees of base timing with total advance reaching 28 to 30 degrees at cruise showed zero signs of detonation. The fuel was fine, the engines were fine. The only thing that wasn't fine was Chrysler's risk assessment model. This is where the story turns into a lesson on corporate liability versus engineering reality. Internal documents that surfaced years later showed that Chrysler had actually tested timing curves very similar to Eddie's. They ran engines on dynos with 30 degrees of total advance. And guess what? They ran beautifully. They made great power. They ran cool. But the legal department looked at the data and asked, what if one engine in 1,000 detonates? What if one guy fills up with bad gas at a sketchy station in Death Valley and blows a head gasket? The liability risk of that 0.1% failure rate was deemed too high, so Chrysler chose the conservative path. They decided it was better to have every engine run poorly, safely poorly, than to risk a fraction of a percent running catastrophically. It made sense to the lawyers, it made sense to the accountants, but to a mechanic like Eddie, it was cowardice. It was bad engineering. The efficiency gains Eddie documented weren't magic, they were just thermodynamics. By advancing the timing, he was recovering energy that Chrysler was throwing away. And the emissions part? That's the most ironic piece of the puzzle. The lean burn system was supposed to reduce emissions. But because the timing was so late, combustion was incomplete. The mixture was still burning when it left the cylinder. The catalytic converters were trying to clean up an exhaust stream that was full of unburned hydrocarbons. It's like trying to clean a floor while someone is still dumping mud on it. With Eddie's timing, the combustion was finished inside the combustion chamber. The exhaust coming out was cleaner, cooler, and chemically stable. The catalytic converters could actually do their job. Eddie Martinez hadn't just made the cars faster, he had made them greener. And he did it by ignoring the emissions regulations that were choking the industry. Now, here is the ultimate vindication. If you fast forward to the early 1980s, you see something fascinating happen at Chrysler. As computer technology improved, the lean burn system was eventually phased out for more modern electronic fuel injection and legitimate engine management systems. And if you look at the factory timing maps for a 1984 Chrysler V8, they look almost identical to what Eddie Martinez was scribbling in his notebook in 1976. By the early 80s, Chrysler was running aggressive advance curves. They were running 20, 24, 28 degrees of total timing at cruise. They had finally caught up to the guy in the parking lot. They had realized that the engines wanted that timing, that the fuel could handle it, and that the efficiency gains were too good to ignore. But did they ever admit it? Did they ever issue a press release saying, "Hey, remember that mechanic we fired? He was right"? Of course not. Corporations don't apologize. They just quietly update the specs and pretend the previous 5 years never happened. They stole the answer key, got an A on the test, and expelled the student who wrote it. The engineering truth was simple. Eddie Martinez understood ignition timing better than the collective brain power of the Chrysler engineering team. Not because he was smarter, but because he was looking at the reality of the engine in front of him, while they were looking at liability charts and worst-case scenarios. This brings us to the legacy of the man himself. You'd hope for a happy ending here. You'd hope that maybe GM hired him, or he started a massive performance parts company. But real life isn't a movie. After Chrysler blackballed him, Eddie Martinez never worked for a major dealership again. The "do not hire" note on his file was invisible but effective. He was the guy who caused trouble, the guy who wrote letters to the president. Dealer principals talk. Nobody wanted the liability. So he did the only thing he could do. He opened his own shop, an independent garage in Phoenix, specializing, of course, in Chrysler products. And for the next 30 years, that shop was a sanctuary. It was the place he went when the dealership told you it can't be fixed. It was the place he went when you wanted your car to run right. He stayed busy. He made a living. He retired in 2005. But the industry that he tried to save, the industry he tried to help, never acknowledged him. I tried to track him down for this story, thinking maybe I could get an interview. I found an obituary. Eddie died in 2019, at the age of 83. The obituary was brief. It mentioned he was a loving father, a grandfather, and the mechanic. It didn't mention that he had outsmarted a billion-dollar corporation. It didn't mention that his timing modification had likely saved millions of gallons of fuel over the years. It didn't mention that he was a hero to thousands of frustrated car owners in the 1970s. But while his name faded, the modification didn't. The lean burn fix lived on much longer than the cars themselves. Through the late 70s and well into the 80s, it became part of the canon of automotive knowledge. It was passed down from master mechanic to apprentice. It was written on scraps of paper taped to the walls of service bays. If it's a lean burn, give it 15 degrees. It became a rule of thumb, a piece of tribal knowledge that survived despite every effort to suppress it. And that, in a way, is a better legacy than a plaque on a wall. Here's the thing. We look back at the lean burn saga and it's easy to feel superior. We have cars now that can drive themselves, cars that make 700 horsepower and get 30 miles per gallon. We won the war on efficiency. But in winning that war, we lost something vital. We lost the ability to touch the machine. The Eddie Martinez timing trick represents a moment in history that we will likely never see again, the era of mechanical democracy. In 1976, if your car ran poorly, you could fix it. You didn't need a software license. You didn't need a proprietary scan tool that cost $5,000 a year to update. You didn't need to hack into an encrypted ECU. You just needed a wrench, a timing light, and the courage to think for yourself. Today, that same improvement requires a degree in computer science. If you try to modify a modern car to run better, you aren't fighting a service bulletin, you're fighting the Digital Millennium Copyright Act. We have traded mechanical simplicity for electronic perfection. And don't get me wrong, the gains are real. Modern engines are marvels. They are cleaner, faster, and longer lasting than anything from the 70s. But the cost of that perfection was our agency. We went from being operators and mechanics to being users and subscribers. Eddie didn't have knock sensors. He had ears. He didn't have a fuel map algorithm. He had intuition. In a way, he was a human knock sensor. He listened to the engine under load, processed the data in real time, and made an adjustment. It turns out that a human paying attention is often more effective than a primitive computer following a bad program. And that leads us to the broader lesson here. This isn't just a story about cars. It's a story about where innovation actually comes from. We're trained to believe that progress only happens in billion-dollar research facilities. We are told that the experts in the white lab coats have run the numbers, and if they say it can't be done, then it can't be done. We are told to trust the process. But Eddie Martinez proved that sometimes the experts are paralyzed by their own constraints. Chrysler had resources Eddie couldn't dream of: wind tunnels, mainframes, testing tracks. But they also had constraints Eddie didn't have: corporate politics, legal liability, quarterly earnings targets, and the terrifying fear of being wrong. Eddie just wanted to make the car run better. When you strip away the bureaucracy, engineering becomes simple again. Does it work? Then it's right. How many other simple solutions are buried in corporate archives right now? How many other Eddie Martinez figures are out there in different industries, in tech, in medicine, in agriculture, who have figured out a better way but are being silenced because their solution is inconvenient for the bottom line? How much knowledge has been lost because it threatens someone's credentials? Maybe the battery technology we need isn't being held back by physics, but by a patent portfolio. Maybe the fix for a common software bug is known by a junior developer, but implementing it would require rewriting a legacy codebase that no one wants to touch. The banned ignition trick reminds us to be skeptical of the phrase, "It is what it is." Usually when someone says that, what they mean is, it is what we decided it should be, and we don't want you to change it. Today, when we're facing massive new challenges, questions about sustainability, repairability, and the future of transportation, maybe we should channel a little bit of Eddie. Maybe we should remember that sometimes the best solutions aren't the most complex ones. Sometimes they are just one person standing in a hot garage, thinking clearly, and having the guts to say the emperor has no clothes, and his timing is retarded. Eddie's timing trick embarrassed Chrysler so badly they spent millions trying to suppress it. But the physics didn't care about their budget. The modification worked so well that they eventually had to adopt the same principles in their later designs. One mechanic in Phoenix proved that corporate engineering isn't infallible, that simple often beats complex, and that truth eventually wins, even when powerful forces try to bury it. So the next time someone tells you that you can't question the experts, that the engineers know best, that corporate has done the research and you should just trust them, remember the banned ignition trick. Remember the 1976 Cordoba that couldn't get out of its own way until a guy named Eddie rotated the distributor 17 degrees and made Chrysler look foolish. Sometimes the best engineering happens in parking lots, not research facilities. Sometimes one person with a wrench knows more than a department full of degrees. And sometimes the modification that works so well it gets banned is exactly the one you should be paying attention to. We need to keep that spirit alive. We need to keep looking for the 17-degree twist in our own lives. Because if we stop looking, if we stop questioning, if we just accept the factory specs as gospel, then we're just passengers. And personally, I'd rather be a mechanic. What other simple tricks are out there waiting to be rediscovered? What knowledge has been buried because it was inconvenient? The Eddie Martinez story reminds us that innovation doesn't always come from the top down. Sometimes it bubbles up from the bottom, from the people who get their hands dirty. It comes from staying late on a Saturday, trying one more thing, and refusing to accept that good enough is actually good enough. That timing trick Chrysler never wanted you to know about, it proved that questioning authority, testing assumptions, and trusting your own observations can beat the biggest engineering departments in the world. And 50 years later, as we stare down the barrel of a new era of sealed hoods and locked software, we are still learning that lesson. This is Legacy Motoring. Keep your eyes open, keep your tools handy, and never be afraid to void a warranty in the pursuit of the truth. I'll see you in the next one.